All right, boys and girls, good day to all. It is all about them circles. Today, we will understand radian measure of an angle as the length of the arc on the unit circle subtended by the angle. Explain how the unit circle in the coordinate plane enables the extension of trigonometric functions to all real numbers, interpreted as a radian measure of angles traverse counterclockwise around the unit circle. Woo! So you know we're gonna be busy for some days, right? But before we do that, we gotta touch up on some geometry. We gotta use similarity to determine that the length of an arc intersected by an angle is proportional to the radius, and define the radian measure of an angle as the constant of proportionality. And you have to derive this formula of an area of a sector. You don't have to really derive the area because that's going to be taken care of. And then you also have to talk about all circles are similar. Circles with the same central angle have arc lengths that are proportional to the radius. The radian measure of an angle is the constant of proportionality. Whew! That's a lot that we gotta deal with, but we're gonna make it. All right, question. What does it mean to do your work? Help me understand that. Because students like to say, and I used to say it too when I was your age, I do my work. I'm doing my work, and you be doing 15, 20 other things that takes priority before the work. So I want you guys to tell me what does that mean. All right? Do not forget to get points on that participation log. You must be focused, make comments towards the math, conversing with teachers and or students about math. Electrons are put away when required. So usually I tell you, okay, all electron needs to be put up, Chromebook, all of that. So I need for you guys to be in compliance with that. And again, if you're not compliant by it, I don't even pay you no mind. Even if you are putting numbers on your paper, you must show me every bit of detail. All right, boys and girls, let's find the area of a set of the sector. What general formula can you develop based on the information? Take a moment to think about that. As I told you about one of the things that we have to get into, we gotta set this up like a proportion. So there we are. Area of the circle, the area of sector, sorry, divided by the area of the circle equals the central angle divided by 360, which we got all that going on here. All right. So again, if you forgot this from wherever teacher you have, please don't feel bad. It's all right. I'm a touch basis on it. All right. So we did a setup. So let's go ahead and get the work done. Because we don't know the area of the sector, but we know the area of a circle, which is pi radius squared. 120 divided by 360. Because that's how many degrees we have. All right. So 360, that's by doing the butterfly method. All right. So let me slow down here. So all I did here is just took this information, this 120 times 3/4 times 2 squared. I just multiply all of that. And then 360x equals that guy. So now I have to divide it out, both sides by 360. And my final answer I should get is 4186 by rounding up to 419. Just like that. I'm not asking you to find the arc length or nothing like that. You solved the proportion. Solved the proportion. You solved it, and we've been dealing with proportions all this week so far. All right, it's time to do those rotations, clockwise versus counterclockwise. In class, we have a worksheet on this already. My online people, just follow along. You will get the same practice. All right. So guys, you deal with the terminal side. So if I'm saying the terminal side, you know this what I'm talking about? So if I'm saying the terminal side, all I'm saying is things are going to go into a clock into a counterclockwise motion. That's what I want you to see. So if I say the initial side, if I'm saying that, I'm saying, well, let's go clockwise, go around the clock. That's all I'm saying here. So again, I'm just giving you guys this in small doses. You was taught this last year. If you forgot, I just only could touch only so much. All right. So look, let's go ahead and talk about the terminal side of these things. So here's what I'm asking you. This 100 degree, I want to ask you which axis would this land in? Which axis would this land in? Well, it won't be in quadrant one. I don't know why I say axis, I mean quadrant, y'all. Because quadrant one is 90 degrees already, so it's a little bit over here. Just a little bit. So that's in quadrant two. That's what that be. So negative 150 degrees. All right. So because it's negative, it's going to go clockwise. But how do we figure out where it should be in? Here's how I would tell you what to do. Oh, I'm sorry. So just go backwards. So you're going to go this way. So if I'm right here, I'm in negative 90 degrees already. But if I move closer, guess what? I'm almost halfway full. So I'll be at quadrant number 3. All right. So let's do 395. So I already did my whole complete circle. And because it's positive, I'm going to be going to the counterclockwise notion. So I'm going to be somewhere over around here. And to find out which quadrant it is in, personally, I like to subtract 395 minus 360. that's going to be right somewhere over here. So this is quadrant 1. Just like that. Nothing too much going on. All right. So in this one, I mainly am asking you to give me a positive and negative coterminal angle. And this is pretty easy. So give me a positive of 50. So when I'm saying positive coterminal angle, I'm asking you to add 50 to 360. What's 50 plus 360? 410. So what if I say give me a negative coterminal angle? So you're going to take 50 again, but you're going to subtract it from 360. And that's negative 310. And it's just the same thing. Y'all don't worry about these numbers here. Cause I know the numbers throwing y'all off. Alright. So let's do 420. So 420 plus 360, that's 780. Alright. So let's do a negative one. 420 minus 360. And that's just 60. So we both know that this is going to be like somewhere over here somewhere. Alright, so let's do negative 120. So let's add negative 120. So negative 120 plus 360. That's 240. So that's somewhere over here. Alright, so let's go negative 120 minus 360. And when we do that, we get negative 480. Alright, just like, oh, I'm sorry, just like that, y'all. So again, this is called coterminal angles. Alright, y'all, so let's move on. Alright, let's use some trig ratios as a Pythagorean theorem to solve these right triangles. So what if I have something that looks like this? What trig ratio is that? So we got an opposite and we got a hypotenuse. Well, we should know this. It's sine. Sine over 4/5. Opposite over hypotenuse. So let's go ahead and do this trig Pythagorean theorem. So 4 squared plus x squared equals 5 squared. So 16 plus x squared equals 25. And then when I subtract 16 from both sides, x squared equals 9. And then if I square root both sides, I get x equals 3. It's just like that. All right. What is this one? This one is cosine because it's the adjacent, which is 6, over the hypotenuse, which is 10. All right. Then we got to derive an equation from a circle given the center and the radius using the Pythagorean theorem. Then we got to complete the square to find the center of the radius of a given circle by equation. So this is stuff that you did last year. So let's get through it. So what do we know about circles? Well, they have a radius and all the points have the same distance from the radius. All right, so now we got to create an equation with the radius r, the center h and k, and x and y. So look, ask yourself this question. We see that we got 2 points, right? H and k, x, y, and we have a radius. What equation you gonna think about using? All right. Why don't you not use the distance formula? So the distance used to go from the outer minus the inner. So let's do it. All right. If we know we're trying to find the radius of this, all thing we have to do is just square both sides, and you get r equals h minus x squared plus y minus k squared. Just like that. All right. Whew. So we created the equation, but now we gotta go a little bit further with it. And why and how does this connect to Pythagorean? Well, it connects to the Pythagorean because guess what? We created a triangle from the circle. So that's why. Also, the hypotenuse is what? The hypotenuse is your r. And we know r, when dealing with circles, r is your radius. So that's what we know about. And then from there, we should have a beautiful formula. And let me erase the stuff that I had going on from behind. and you need that part, just replay that replay that part of the video. That when I was talking about R being the radius and R we know it to be the hypotenuse. And there. So we use the knowledge of the Pythagorean theorem to give us a I would like to call this the updated Pythagorean. So that's what I would call this the update one because you're using not A, B, and C. You're using, the X coordinate, the Y coordinate, and you're using the radius of a circle. So that's why. And I will be asking some good questions from this on the quiz. That sounds like some quiz material. All right, give me the standard equation of of the circle. I don't know why I put each. It's just one circle. All right. So ask yourself this question: what's the radius of all this? So if I got radius here, that's 3 going horizontally and 3 going vertically. So at least I know what my radius is. And what's my center? My center is the origin point. Remember, I don't know if I said this or not, but H and K is your center points. H and K is your center points. And this is just me just drawing, just so you can see what I'm trying to get at. All right, here's my equation I need because my radius is 9, and H and K again is my center, so I don't. Because it's at the origin, I don't need to write it in this. I used to just do it like that. So no, I don't need this. I don't need that because of my radius. I mean, my center point is just at the origin. All right. All right. So a circle with a center 0, 9, and the radius 4, 2. How will I create such an equation like that? Well, I don't know what x and y is, but I know my center. So x minus 0 square plus y minus a negative 9, of course, square equals 4.2. All right. So when I rewrite this, I will have x squared because 0 to any power is just 0. And then when I get to plus y, two negatives make a positive plus 9 square. I forgot the square root of 4.2 should equals 17.64. And that's all you have to do with that equation. So just go back to the this to the distance formula that we use to create the first Pythagorean theorem formula related to this, and you should be fine with this one. All right. So what's the point of a circle? So if I have a point -5, 6, and a circle with a center -1, 3, what is the standard equation of the circle? So going back to what you did in the very beginning of this circle stuff, you know how we did to create the radius? That's what you want to start out with, just like that. So you can subtract between the two because you gotta find out what the radius is. You didn't know that. So when you subtract from the two, you do get 5 from the 2 points, that is. Alright, next, just put in the formula. Notice that x is y is no longer used because you don't really necessarily need that. Because you use only x and y to get the distance. So, don't make the mistake to use an x and y in this last step. And there we have it. You have the equation that you need. And again, that's the distance formula that we use to give us our radius. And our radius is the hypotenuse. And I'm finished with this problem. Alright, let's finally do it. So let's understand radian measure of an angle as the length of an arc on a unit circle subtended by the angle. But before we get into all of this, if this is a circle that we're going to create, we got some other things that we need to contend with, such as dealing with a radian. A radian is an angle of 1 radian is defined by the angle in the counterclockwise direction at the center of a unit circle which spans an arc length of 1. That's some important stuff that I would be questioning you on, so you may want to know what all that means. Unit conversion. So to get a radian, you're going to have to convert some stuff. What do you mean by converting, Mr. Howard? Well, let me show you a fine example. So suppose I'm trying to find the radians, but if I have a degree of 10 degrees, well, I know, according to this formula, I have to do all that. So when I multiply across, I get 10 pi over 180. Well, so when you guys are dealing with the radians, you always going to simplify every radian that you deal with. So we could simplify this, can we? So let's simplify this. So when we simplify this, obviously you just get rid of zeros. And you have pi over 18. Because what's left in the numerator is just pi. I mean, you could say 1, but 1 over 18 pi, who cares for that? But mathematicians want answers to look like this. All right. And you're going to do that for, let's do this for 20 degrees. So if I have 20 degrees, so 20 divided by 180, let's do this. So that is going to be 20 over 180, which we could simplify to just pi over 9. Just like that. Oh, let me fix my pi symbol. Y'all looking like, is he trying to draw a hand, man? Ew. There we go. It's done. And that's essentially all you're doing for that conversion. And when we are making our unit circle, we have to know all of that. So this is very important that you have to do. All right. We towards the end of our little lesson. Deal with types of triangles. So the 30, 60, 90 triangles, 45, 45, 90 triangles, these are essential because you're going to see this as we make the unit circle and its connection to the Pythagorean theorem. So let's get started with a 30, 60 triangle. So when you're working with these triangles, you always take the opposite leg. That's just the opposite leg, right? The adjacent leg is always going to be x times the square root of 3. And then the hypotenuse is going to be just twice that, twice the short leg. I mean, twice the opposite leg. All right. So let's do an example quick. And this is the 30, 60. So I'm going to put 30 there so you can know. And let's just do an example. So if my A is 6, and then if my B is 6 square root 3, well, let me place this on top. And then I gotta find what C is, and I don't know that. How will I find that? Well, we gotta use the Pythagorean. So the stuff in red is what I'm looking for. So 6 squared plus 6 square root of 3 squared equals R squared. We're gonna use R. R is C if you want to use C. Because we know R is radius, and we know the radius is the hypotenuse, which we're trying to find. So we know that 6 squared is 36. And we know 6 squared. Ooh, I'm sorry, y'all. Is 36. Right? But remember, when you got a square root, What's the reciprocal or inverse of the square root? Well, 3 squared. So if I was to put a square here inside of that, guess what happened to the 3? It's just 3 by itself. So 36 times 3, because that 3 is by itself. So 36 times 3 is what? 108. So 36 plus 108 equals r squared. R squared is, again, is radius. So we get 144. And from there, we got to take the square root of both sides. When we take the square root of both sides, r equals 12. So we just figured out the hypotenuse for the 3060. And it's just like that. So remember, the hypotenuse is always going to be twice the opposite leg. And the adjacent leg is the square root of 3 times the opposite. The opposite leg. All right. So that's for the 3060. Now let's do the 45, 45, 90. So to do the 45, 45, 90, just a rule to remember. The opposite leg is going to have a measure of x. So if that's x, well, the adjacent leg is going to have the same measure as the opposite. However, your hypotenuse is going to be x times the square root of 2. So let me give you a fine example of this. So suppose you got the opposite leg to be 5 and b to be 5, too. But we got to find out what c is, or r. So you could write this as I'm tripping. Write this as 5 squared plus 5 squared equals your radius being hypotenuse. So we know it's 25 plus 25 equals r squared. So that's 50 equals r squared. Well, when you take the square root of both sides, you got to think about how to break down 50. And that's what makes this hard. Because you got to break things down like that. Because we know that 50, when you try to break it down into perfect squares, 50 has 25. And we know 25 is a perfect square of 5. So that's 5 square root 2. And that's our r. Just like that. And that's pretty much what this lesson's about. So by next class period, we should be working on the unit circle. We should be able to create it in its entirety. And do some trig ratios from it too. So